All right, here are those for simplifying radicals. So this is accomplished by evaluating the numerical part and then finding the largest groupings for our variables. So when we're simplifying the numerical portion, we do the prime factorization. That's the factor tree. Then we use the index of the radical. So the index is the type of root you have. So cube root, the index is 3. We're looking for groups of 3 for a fourth root, groups of 4. Square root doesn't show the index, but groups of 2. Variable portion, 2 ways to do it. We can do a prime factorization. The simplest method is done by dividing the exponent of the variable by the index. That's how many come out. The remainder is how many stay behind, but I'll do the full factorization for the first couple here. So when we start, we actually break our thing apart into separate terms. So for numbers, we do prime factorizations. So 2 times 2 times 3. How you do the prime factorization is up to you. I prefer to take out the smallest number possible. So every single time, because then it's always grouped. So the pair comes out, anything left behind stays inside. So x cubed, if you want to think about it in terms of prime factorization, is x times x times x, group of 2 x's, and 1 stays behind. Y to the 5th, 5 y's, 1 group, 2 groups, so 2 y's come out, 1 stays behind. So to get our final answer, we actually, these are technically multiplication problems, we multiply everybody back together. So things outside multiply together, 2 times x times y times y, 2xy squared. Things inside together, root 3 times root x times root y would be root 3xy. 2 is a little bit different. Obviously, we got that 4x cubed out front we'll have to keep track of. So we've got the 4x cubed, we've got the root 175, we've got the root x cubed, we've got the root y cubed. So for 175, that's going to be 5, and let's see what we get here. 175 divided by 5 is 35. 5 again, 5 and 7. So we've got a pair of 5s. Oops, sloppy there. So this 4x cubed is actually just going to come all the way down. So there's no simplifying there. 5 outside, 7 left over inside. X cubed we already just did up here, so it's going to work the same way. It's going to be x root x. Y cubed, the letter doesn't matter, so y cubed is going to be exactly the same as x cubed, so y root y. And we put everybody together. 4 times 5 is going to be 20. For x's, we have x cubed and x, so that's going to be x to the 4th. Y, and then inside, we're going to have the 7, the x, and the y, so 7x, y. All right, so for this one, we'll split up. So we got 150, we got root x cubed, we got root y to the 4th. So 150 is 2 and 75, which is 3 and 25, which is 5 and 5. X cubed we've done before, it's just x. Well, we'll bring it down here. X root x. Y to the 4th is 4 copies of y, so nothing left over. So here we've got a pair of 5s. And because the 2 and 3 don't have partners, they multiply just back together underneath the root. So combining everything, we got 5 outside, we got x outside, and we got 2 y's, so 5xy squared. Inside, we got 2 times 3 times x, so that's going to be 6x. All right, let's look at the next one here. So 4, once again, we got this guy sitting out front, so we'll have to keep track of that. So we got an xy cubed, root 9, root x squared, root y to the 6th. So this one's just going to come down because there's nothing to simplify. 9 is a pair of 3's. X squared is a pair of x's. Y to the 6th is 6th. 4, 5, 6 y's. 1, 2, 3 pairs. If you notice in this one, nothing's left over. So numbers, we've got 3. X's, we've got x times x, so we've got x squared, and y's, we've got y cubed, and then 3 more y's, so y to the 6th. All right, so for cube roots work similar, except we're finding groups of 3. So I'm going to talk about the division shortcut for the exponents here. Numbers still have to be done the same way. So y squared, cube root of 875, cube root of x to the 4th, cube root of y to the 10th. So the y squared is going to come down. 875 is definitely divisible by 5. It is 5 and 175. 175 was 5 and 35, which is 5 and 7. So we've got 3 5, well, I'm going to circle them. 1, 2, 3 5s, we need to cube root So we're gonna have 5 outside and cube root 7 left over. So to do the division shortcut, what we're looking at is how many times does 3 go into 4? 3 goes into 4 once, so a single x comes out, and it leaves a remainder of 1, so a single x is left behind. On the y, 3 goes into 10 3 times, leaving 3 y's to come out, and it leaves 1 behind. The remainder would be 1, so it's going to look like this. So put all together, kind of sloppy here, numbers, we got 5. X's, we got the single x here. Y's, we got y squared and then 3 more, so that's y to the 5th, 7x and y. So cube root 7x, y. So make sure you have the cube root symbol there because the cube root and square root are not the same thing. Okay, so for this one, we got x, we got the cube root of 625, we got the cube root of x to the 5th, we got the cube root of y to the 5th. So for this one, 625 can be divided by 5. That's 125, can be divided by 5 again. That's 5 and 25, divided by 5 again, 5 and 5. So using our, let's see, so x comes down. We have 1, 2, 3 5s. So a 5 comes out with 1 left over, stays inside, off the screen, sorry. So for x's, 3 goes into 5 once, so x comes out, and 2 are left behind with the remainder. Similar things can happen here. 3 goes into 5 once, so a y comes out, and then 2 y's are left behind. So if we put this all together, we've got 5 x squared y cube root x squared y squared. All right, so for 7, let's see here, we've got 7y cubed, we got the cube root of 8, we got the cube root of x to the 5th, we got the cube root of y cubed. So 8 is 2 and 4, which is 2 and 2, which is a group of 3, so that's just 2. 3 goes into 5 once, leaves 2 x's behind. 3 goes into 3 once, leaves nothing but, so no root. So bring down our 7y cubed. So altogether we got 14, 2 times 7, x, y to the 4th, y cubed and y, and then our cube root of x squared. All right, last ones. Okay, so for 8, just higher order roots or any order root. So 4th root, we're looking for groups of 4, but procedure is the same. The 4th root of 256, the 4th root of x to the 18th, and the 4th root of y to the 8th. So we're going to answer these a little bit differently. Because that number is so large, I'm going to check and see if 256 has a 4th root, which you can do in your calculator, and it does. So 256 is a perfect 4th. It is just 4. So the other way is if we want to use fractional exponents instead. This is going to be, since we're doing division, 18 divided by 4, and for y it's going to be 8 over 4. So 4x, if I reduce that, that's 9 halves. If I reduce that, that's squared. So this would be 4x to the 9 halves y squared in terms of exponents. So for here, we've got the cube root of 27, we've got the cube root of x to the 9th, we've got the cube root of y to the 7th. So that 27 is in fact a perfect cube, it's just 3. So x to the 9 thirds, and then we've got y to the 7 thirds. So 3x cubed, 9 divided by 3 is 3. That doesn't simplify. So 3x cubed y to the 7 thirds. All right, our last one, the cube root of 216, cube root of x to the 15, cube root of y to the 6th. Let's see if 216 is a perfect cube. It is, it's 6. So 216 is a perfect cube, it's just 6. So x to the 15 thirds, y to the 6 thirds. So 15 thirds is just 5, 6 thirds is 2. So 6x to the 5th, y squared. So you can also write them with fractional exponents instead of doing it the other way. All right, and that is the end of the section.